Hi, let's solve today's daily challenge, that is furthest building you can reach. So in this question, we are given an array heights which represents the heights of buildings, and we are given some bricks and some ladders. Okay. And then we have to start the journey from building 0 and move to the next building by possibly using bricks or ladders, right? So here we are given some bricks, ladders, and we have a choice to use either bricks or ladders, right, to move to the next building. Now, while moving from building I to I plus 1, if the current building's height is greater than or equal to the next building's height, you do not need a ladder or brick. Okay. If, let's say, the current building's height is more than the next building's height, then we can directly jump onto that building, right? We don't need any ladder or bricks. But if it is less than the next building's height, you have to use either one ladder or h of I minus 1 and h minus h of I bricks. Okay. And doing this, you have to return the furthest building index you can reach if you use the given ladders and bricks optimally, right? So here also is one GIF that shows what you have to do. Here, if you're standing here, you can directly jump onto the building if the next building's height is less than the current building's height. Then this building's height is less, right? So you have to either use brick or ladder and move to the next building, right? So let me come here and try to showcase it to you. So this is the case that is given to us. That is, there are heights. So I have already drawn these heights, these buildings, and we are given some bricks and ladders. So if the current building, this is the current building and this is the next building, its height is less, so I can directly jump here. But when this is the scenario, when the building current building height is less than the next, then you have to use either bricks or ladders. So in this case, what can be the possibility? I can use how many bricks? 4 minus 2 bricks, right? Sorry, this is the heights, right? This is 2 and this is 7. So either I can use 5 bricks here or one ladder here, correct? Similarly, okay, now after using 5 brick or one ladder, I'll be here on the building 7. Then I can directly jump onto the next building because its height is less. Then again, the height is more. So we are here. This is 6, this is 9. So we either require 3 bricks or one ladder, right? Okay, then we have 14 and then we have 12. Now again, from 9 to 14, if I have to go, how many bricks do I require? 5 bricks or one ladder I can use, correct? And then from 14 to 12, I can directly jump. So this is the case, right? If I want to go from building 0 to building n, right? I have to use how many number of bricks? 5, then 3, then 5, or 3 ladders, right? Or I can skip, like, let's say here I use bricks and here I use ladder and ladder, etc. So there can be combination of both, right? Okay. So now how can we solve this question? That is the point. And here bricks and ladders given to us are limited in number. So it is also possible that while going from building to building, let's say we exhaust at ninth building or 14th building, that is, we are not able to go to the nth building. So that is the question. You have to return the furthest building that you can reach. Now let us see what we can do in this question here. So let's see. Let me remove these. Okay, we have one ladder here. So here I can use 5 bricks or one ladder. Let's say I choose to use 5 bricks over here. Okay. So here one ladder will be left. Correct. Because after using these 5 bricks here, the remaining bricks will be 0. And then we will only be having a ladder and that will use here. Or we can also do vice versa, that use some bricks here or use a ladder here. But both the cases will yield us the same answer, that is, we will go and stop at the 9 number building, okay, 9 height building, so which is the fourth building, right, because it is 0 indexed. So that is what we have to return, right? So I hope you have gotten the question. Now let us see how we have to solve it. So for the solution, you can observe one thing, that ladder can be used in any height difference, right? The height difference doesn't matter in case of ladders. So the height can be as major as 5 bricks, or here the max is 5 bricks, right? 5 units, right? Correct. So the ladder can be used anywhere, even it's 7, 9, 10, 11, 12, 100 even, right? So ladder can be used. But bricks cannot be. Bricks will be decrementing with how many units? H of I plus 1 minus h of I units. So these are the number of bricks that we have to use. Bricks have to be used like this. So what we would try to do is, because ladder can be used in any scenario, right? So what we'll do, let's say I have 5 bricks, right? I have 5, 3, 5. Okay. So here, when I have 5 bricks, I will say, no, don't use the 5 bricks, go to the 3 and use 3 bricks, the minimum number of bricks that you can use. Okay. So that some bricks are left in case after a point I exhaust the ladders, I can use the bricks. Correct. So wherever I have the height difference less, there I have to use bricks. So that is sure. Ladder can be used anywhere in any height difference, but bricks have to be used wherever the height difference is the least. Correct. So that is what we have to do. So, as we know, what we want to do is, as we go along and iterate through these buildings, right? We want to store these bricks difference, right? Sorry, the amount of bricks that we would need, or the height difference somewhere, so that whenever we get the element out of it, it is the least element, right? We need to get the least element. So for that we can use priority queue or a min heap. Correct. So what min heap will do, you will keep inserting these values, right? So you will insert 5 and 3. So now the only catch here is, the priority queue concept is very clear to us, right? But when do we have to, get everything out from the priority queue? When I have elements more than the number of ladders inside the priority queue. Because obviously, let's say, as I come here, right, I'm iterating in this array. I come here, so I see here I need 5 bricks. So what I'll do, I'll put it inside the priority queue. Correct. After putting in the priority queue, I notice that I have one number of ladder and one element is present, so I can use ladder. Why do I have to worry about using bricks then, right? Okay. Then as soon as I enter 3 here, then what will happen? As soon as I enter 3, I can see that either I can use the ladder here or here, correct? So here the number of the elements inside the priority you have exceeded that of the ladders number, right? So you have to now use bricks in this case. Okay, so which how many bricks you have to use? You have to use the least number of bricks, right? So that you will have only with 3, so you'll remove 3 from the priority queue. So 5 will be here and the bricks amount will be reduced to 2. Then you will go to another high difference, that is this. So here you will insert this here. Now again, your quantity is more than the number of elements are more than the number of ladders. So you'll say take out the minimum value. So here the minimum value obviously is 5. So you don't have the required amount of bricks here, right? So you don't have the required amount of bricks as well as ladders to satisfy for this condition. So you'll say I'll stop here and I have to return this building only. So in this case, I'll simply return 4 index. That is, I could only reach up to 4th building by using bricks or ladders, right? And this is optimal, right? This is optimal. That is, this is the furthest most that you can go. So I hope it is clear to you. So the question is quite easy if you understand what you have to basically do after you create the priority queue, right? That is, you compare its size with the number of ladders, right? If the number of ladders are now less than the number of elements that inside of the priority queue, so you have to take the least element from the priority queue, right? The top element of the priority queue, and you have to remove it from the bricks. So as soon as your bricks reduce to less than 0, you have to simply return the current index you are standing at. Okay. So now let us go ahead and quickly code this out. So for here, let me take int n, which is nothing but heights dot size. After this, I'll iterate in this array up to n minus 1. Okay. Now what do I have to do? I have to check, right, the height difference. Also, let me create the priority queue here. So priority queue is going to be containing an integer, and because it's going to be a min priority queue, so you have to also pass these two parameters here to convert it into min priority queue, because in C++, when you declare priority queue as only int, then that means a max priority queue. So in case of min priority queue, you have to pass these two as well. All right, then we have to check if heights of I plus 1, right, is more than heights of I. Then you have to put it inside the priority queue. That is, then you would have need some bricks, right, or ladders, right? But we are not right now sure what we have to use, right? But still, we need to know what is the height difference here, and that we have to insert inside of the priority queue. So I'll say insert heights of I plus 1 minus heights of I. After creating the priority queue, while looping here only, you have to check if pq.size has exceeded the amount of ladders we have, right? If so, you take out the top element of the priority queue, which is the least element, right? Least number of height difference or the bricks that you have to use, and you subtract that. First, pop this element from the priority queue and subtract that from the amount of bricks you have. Okay, after this, if the number of your bricks becomes less than 0, you have to simply return I. Okay, and that's it. That is the whole logic that you have to do. After this, let's say you don't quit here, right? You still have some amounts of bricks. That means you can easily reach up to the last index, right? So the last index is n minus 1. So here simply return n minus 1. So that is it. That is all you have to do. Now, let me quickly run it and show you if it works. Okay. Okay, spelling is wrong here. Okay, so it's accepted. So this is basically how you have to solve this question. Now talking about the time complexity, as you can see, you're only iterating once inside of the heights array, and you are also pushing these elements inside of the priority queue. So this push operation will take login number of operations, and this for loop is going to take n number of operations. So in total, it's going to be n login operations. And talking about space complexity, it will be big O of n because of the priority queue. So that is all about this question.